Now look at that, it faded over again. Oh, good morning, good afternoon, good evening, whatever time it might be where you are out there. Welcome back to the live stream. My name is Jeff Fritz, and this is C# with CSharpFritz. How you doing there today? It's so sunny outside. Look, it's beautiful. It's always sunny in Philadelphia. Great to see you. How we doing there in the chat room? I see a bunch of folks already here. Look at this. Apricot, good to see you. Burger Bee, good morning. Stephen Thusen, hello, hello. Ready to hear some of that C#9 goodness? Absolutely. We're going to get into that today. Kate's Chevers, good to see you. CTI Geek, good morning, good morning, good morning. Is that Peppy K30 or is it Pepic 30? Hello, hello. Mona 1984, good to see you. Apricot, we don't talk about things that aren't C#9 here. We stay on topic for these sessions. This is not AMA. This is a very beginner-friendly stream that we host, talking about things in C#, and we're going to get into C#9 today. I am in security mode. That's right. We're going to make plenty secure code here. Yeah, something like that. How you doing there, Rick? Good to see you. Surly Dev is here. Good afternoon. Layla Codes it. Good to see you. How you doing, my friend? Pip Daddy G, how you doing? It's always sunny in Philadelphia. It's always sunny. No worries. It just is. That's the way things are. Am I right? So, no problem, Apricot. We do that on a different channel. It's easy to get confused. So, we want to make sure that these sessions stay very beginner friendly, stay very focused on the topic of C# so that we can get through the content. We want to make sure that each session, each time we get together here on this stream, we get through our lesson together and we stay focused on the topic that we're discussing. So that's where we go through here. It's gray and bleak in Milton Keynes, says Layla. Oh no, so sorry to hear. So we're just on the other side of .NET Conf 2020, and it was a 3-day event, and every year we have .NET Conf. For the past, how many years? The past 10 years, 9 years prior to this year, it was in a September time frame. This year we moved it to November so that we didn't conflict with Ignite, because Microsoft Ignite decided to move to September. So we moved to November, and it worked out nicely because it landed right at the same time as our .NET 5 launch. .NET 5 is now released to the web, released to you, and you can use it in production. It's fully supported, and it's a current release, we call it. That means it's going to be supported until the next version of .NET is released, and 3 months after that. So it's a way for you to stay on the bleeding edge, try new features before the next long-term support version is released. .NET Core 3.1 is a long-term support version that'll be supported for at least another 2 years, and a year after the next long-term support version is released. And right now, the current schedule is we're going to be working to deliver .NET 6, the next long-term support version that will be released hopefully November 2021, about a year out. So we're very excited. If you jump onto .NET 5, you'll be able to stay with .NET 5 until about January, February 2022, when you're encouraged to maintain support to roll over to .NET 6. So there's the long and short of the .NET support cycle. Hey there, Shy Sharp, good to see you. You have a trade deal with Philadelphia. We get all the sunshine. Milton Keynes gets, all the beige, something like that. So, how you doing there, Org Brat? Vin Dallas. I can get into that question. That's a fine question to start things off here. I'll cue that up, and we'll get into that in just a second. Let me get some music playing here in the background before I get into the question. I've been playing Stream Beats from Harris Heller. This is a free, copyright granted playlist of music that's groovy. This one is lo-fi. It's very chill. It's very relaxing, and it's good background music when we're writing code. So I'm going to start this off. You can find this music on Spotify. You can find it on Apple Music, wherever you find music out on the internet. You can find Stream Beats. So thank you so much, Harris, for making it available. You can use it in your Twitch streams, your YouTube videos, whatever you might like. So this is the Stream Beats Lo-Fi playlist we're going to be listening to today in the background. Just enough so that when I pause talking, it fills in and it sounds kind of cool. Yeah, Stream Beats are kind of awesome. So let me, yes, it's very topical when DMCA strikes go out. And I can touch on that question from Mona. That's certainly on topic as we talk about .NET 5 release here. Vindalis had this question first. Why use C# over C++? C++ is a very low-level language. When you're working with C++, you're managing memory, you're managing threads directly. However, for many classes of applications, you don't need that fine-grained control over how you interact with your operating system, how you interact with building your applications. So we have higher-level languages like Java, C#, F#, Visual Basic, Ruby, what have you, that they take advantage of a garbage collector, take advantage of managing threads for you so that you don't need to be concerned about those things and you can focus more on the business value that you want to deliver in your applications. Interact and take advantage of frameworks that are going to build your user interfaces for you more quickly. Be more productive and give up a little bit of control. So that's a trade-off that you might choose. However, with some of the features that are available to .NET Framework and to C# developers, you can reach in and still manage threads and memory directly and efficiently. So much so that right now on the Tech Empower benchmarks, the #1 fastest performing web server is written in C#. The Kestrel web server is currently the fastest web server out there. So to each their own. There are folks that instead of writing games with C++, choose C# and the Unity framework, and you'll see games like Pokemon Go, Fall Guys, Hearthstone, all written with C# and Unity. So to each their own. Where do you want to trade off and give up control? Where do you want to take advantage of productivity features and be able to take those steps and optimize on your own? So a couple different choices there that you can use to interact with your code and hopefully write good applications. And I think what's important here is whether you choose C++ or C#, the #1 feature that hopefully you are choosing for is shipping. You want to ship an application. You want to complete your application, ship it, and have folks use it. That's the most important feature. It doesn't matter how you manage threads, how you manage memory. If folks are using your application, if folks are playing your game, that's the #1 feature you should be concerned about. I'm going to queue up Thunder 16's question there, and WQ Walter. Let me start with Mona's question here, and I don't mind the AMA about C# here real quick. Well, before we get into C# 9. Is there a workaround to let .NET 3.1 and .NET 5 to work side by side on Linux servers? Having many apps with .NET Core 3.1 and now upgraded one to .NET 5, they don't run side by side. They do. When you deploy an application with .NET Core or .NET 5, you can deploy those parts of the framework that you need in order to run your application. In this way, it's what we call a self-contained application. So all the things that you need for it are available, right? And we used to see this with .NET Framework, where we had a shared framework folder on disk, and every application referred to that version of .NET Framework that was on disk. And if you didn't have the correct version of .NET Framework on disk, well, your app wouldn't run. With .NET Core and .NET 5, you can install multiple shared frameworks on a server, and you have the ability to package and run whatever framework features you'd like locally in that folder with your application. Check out the .NET publish command, and you can choose to make your published application a self-contained application, and it'll bring along all of those DLLs, all of those references for you, so that everything to run your application is in one folder and it doesn't reach outside of it. Another option, if you're on a Linux server, is deploy using Docker containers. There's great Docker containers available for .NET Core 3.1 and .NET 5 that you can use, and those run very nicely side by side on Linux servers. Thunder16 asks a question here: is C# a good gateway language for programming into other? I'm not sure where you're going here. C# is an incredibly flexible language that you can use to program anything from IoT devices, Raspberry Pis, NetDuino devices and we also saw the Meadow device that are set up that support .NET and C# out of the box. You can program for watches, for wearables, for mobile devices, phones, using the Xamarin framework that allows you to target those smaller devices. You can program for game systems using the Unity framework I was just mentioning, Fall Guys, Hearthstone, to name two very popular games that use Unity. But you can also program using Xamarin and build applications that run on those systems. You can build applications that run natively on Windows, Mac, or Linux. Build web applications with ASP.NET Core. You can build big cloud services that run out there as well with C#. The world's your oyster. However, wherever you want C# to be, to build an application, to write software, it's there for you. Really great stuff. So, I'll queue up Dracnet's question there. Let me get to WQ Walter's question here. Does C#9 produce code that is more efficient just by recompiling applications, or do you need to modify the code to get advantages? Not so much C#9 gives you more efficient code, but .NET 5 and the .NET 5 runtime will give you more efficient code, and you will need to recompile your application so that it runs in .NET 5. C#9 is a lot of syntactic sugar that, and we'll see as we get into our session here today, that really puts a facade over some of the features that were there previously. It makes it easier for you to interact with launching applications, testing various scenarios using pattern matching. It gives you better ways to create new instances of objects, and it gives you a whole new class of reference objects. And I use class there incorrectly, but it gives you a whole new class of reference objects that you can use called records. It's not necessarily better performing because of C#9. It's better performing because it runs on top of .NET 5, which has a bunch of optimizations in there that are going to make your code faster. Dracnet has a question here about Visual Basic. Is Visual Basic at the same level as C#? This is an interesting question because for a long time at the beginning of .NET, for about the first 10 to 12 years of .NET's existence from the year 2000, there was a very concerted effort to make sure that Visual Basic and C# had the same features. However, with such a tremendous number of developers moving from Visual Basic to C#, there just aren't as many, anywhere near as many developers using Visual Basic as there are C#. And the reason that folks stay on Visual Basic is because it's stable. It doesn't get a lot of changes. So Visual Basic is not getting some of these features. Folks, quite frankly, aren't looking for some of these features, and that's okay. If there are features that Visual Basic needs in order to maintain compatibility with the .NET 5 runtime and other runtimes going forward, it will be enhanced appropriately. That being said, there are no current plans to add significant new features to Visual Basic, but it still works great. There's nobody preventing you or saying you shouldn't use Visual Basic. It's just not a popular language right now. It's still supported and will continue to be supported as long as there are .NET runtimes. So, Chicken Man asks a question here about I'm not quite sure what this means. Does the syntactic sugar C# 9 brings require lowering, and is that bad? I don't know what you mean by lowering. And it's not bad for performance at all. It's a compiler gimmick that happens, and it ends up delivering the same features. This is really something that you're going to see at compile time, and it ends up generating the same IL code. So, all right. Let me head over to our GitHub repository, and we can start talking about where exactly we're going with C# 9 today, and what we're going to be doing. So this is the GitHub repository for our sessions. There you go. You can see the link in chat. If you're watching the YouTube video, the link is just below in the description, out to the GitHub repository. We've been working with .NET Interactive and notebooks so that we can learn some of the basic features of C# right here in the browser. At this time, at the time of this recording, the notebooks feature does not support C# 9 and .NET 5. They're still working on it. It hasn't been deployed yet. At some point in the future, beyond November 2020, this will be supported, and we can come back and update today's discussion, today's features, those samples, so that they work in notebooks. But at the time of our presentation here live today, is not supported. So we're going to be working inside of Visual Studio Code here on my Windows 10 machine to run these tests, not run these samples, talk through the various features, and tinker, break things, learn a little bit more, explore a little bit. So that's something that we're going to spend some time doing here. So, and Dracnet, that's off topic. I'm not going to discuss that. So this is session 11, and we're going to talk about the new C# 9 features. Now, I haven't finished my README for this yet. I got through the first the first 3 sets of documentation here. I want to add more into this, and I'll expand this a little bit further. But all of the samples for today are in sessions, and I have 0111 because this is series 1, session 11, and I think I'm going to do only one more in this series after this. Next week we'll get in, we'll do the promised entity framework discussion, talking about database interaction, and starting in December we'll roll into talking about user interface, and it sounds like we're going to talk about Blazor. Blazor or ASP.NET are the two popular. So we'll get into that next week. Diego asks, how often do I run these sessions? These are once a week. These are on Monday mornings Eastern time here in the States. It's 9 a.m. for me here on the East Coast, 6 a.m. for the folks on the West Coast, and that makes it 2 p.m. UTC time, and I think it's like 6 p.m. in Asia. So, you're looking forward to .NET 5. Well, .NET 5 is here. It's live. It's available. So we'll get into, like I said, we'll get into ASP.NET. We'll get into Blazor starting in December, I believe, is where we left off, where the popular framework was. We put out this question asking folks, well, which framework do you want to see folks talk about? WPF with 27 votes, Windows Forms, sorry, Xamarin 27, ASP.NET Core with 52, Blazor with 50, UWP with only 3, Avalonia with 2. So it looks like we're going to be ASP.NET Core and Blazor. So we'll probably get into ASP.NET Core first and go from there. What the heck? Where did... see this? Somebody ran off with my Glasses cleaner. So what's up with the security hat? I'm securing your code today. We're writing all secure code today. No, it's... I thought it would be funny. I thought it'd be fun. How's that? I've got plenty of hats, trust me. Only today. Only today. No other time we're going to write secure code. Xerxes, take a look at the Microsoft Docs. And you'll find information about how to put a .NET application into Docker. It's really easy to do. There's a template for those containers that you can add to quickly. So I don't want to get too far into it, but I don't mind just pointing you to the docs, and there's some pretty good templates over there. If you're running Visual Studio 2019, you can right-click on your project and add Docker support, and that'll get you right to where you need to be. All right, how we doing here? How we doing? How we doing? What's this? Yeah, that's fine. Okay, keeping an eye here. All right. I think we're doing good. So, so I started the README here. We're going to cover 5 topics today around C#9: record data types, init-only setters, top-level programs, pattern matching enhancements, and we really haven't talked about pattern matching, so I'm going to go in a little bit broader on pattern matching, talk about that, and target-typed new expressions. There is official documentation available. You can click here, jump through to it, and it'll get you right into the what's new in C#9 discussion. But let's walk through and actually execute some of this code. Let's actually go a little bit further and talk about it and make sure that we understand it here together. So first thing you need to know is that you're going to need to install a new version of .NET. So go to .NET, and if you click download, you'll be able to get .NET 5. Now, previously, we went and said, oh, go get .NET Core 3.1. Starting with the version after .NET Core 3.1, it's now referred to as just .NET 5. We're bringing together all the .NETs. There can be only one .NET, right? The idea here is you'll have one framework, one SDK that you can use that just works everywhere. We're almost there. .NET 6, we're going to bring all the mobile in as well so that you have just one .NET. But all the desktop applications, all the web applications, all run inside of .NET 5. So you're going to have to download the .NET SDK appropriate for your operating system and processor architecture, and you'll be able to run .NET 5 locally on your machine. Visual Studio Code, Visual Studio, both need updates so that they support the new framework. No problem. Those are freely available if you go into your .NET 2019 installer. You go into your, Visual Studio 2019 installer, or you go into your Visual Studio for Mac updater. You'll see there's updates available. You can install those, and you'll get support for .NET 5. So, the framework will continue to be supported on Windows. It's a Windows-only version. It is supported by Windows. It is a Windows component. As long as there's versions of Windows, you will continue to see .NET Framework be shipped with patches, security fixes. No dramatic new features are going to be added to .NET Framework unless Windows requires it. So, CTI Geek asks, can I still use .NET Standard DLLs? Yes. .NET Standard is the layer of compatibility. It's almost like a contract that you can use when you're building libraries that will work on .NET Framework, .NET Core, and Xamarin. The next version of .NET Standard version, I'm going to use air quotes because it's not really, is .NET 5. So .NET 5 can consume any .NET Standard DLL. You can reference it and it will be usable on .NET 5. Now, if your .NET Standard DLLs do include the Windows compatibility libraries, your .NET 5 reference of that will only work on Windows. But it can be consumed by it and you can use it. So, yes, there is a chart that you can go to and you can see more about that. I don't want to get too far into that. Regarding .NET Framework no longer being available, no longer being updated, Thindoll is working on a massive web form system for a customer and porting that. There are a number of different ways that you can do this. We've seen folks use .vvm, port to that framework, and that framework is cross .NET compatible. It works on .NET Core and .NET 5. I have a series of components that we've been building that have the same syntax as the default controls in ASP.NET Web Forms. Those work in Blazor on .NET 5. So I had to toot my own project there. So hello. I see Radawar and Pat. Welcome in. Good to see you. So this is where you go to get .NET 5. When you have that downloaded and installed, you'll be able to drop into your Visual Studio Code. You can install Visual Studio Code. Everybody can do this. Free and easy. Go to code.visualstudio.com. And there's instructions to install this on your favorite operating system, whether it's Windows, Mac, or Linux. Available for you to go, grab, install. It is the world's most popular text editor, code editor available. So lots of great features. Integrates with Git, integrates with GitHub, Azure really nicely, and it has a huge ecosystem of extensions that you can use. So in my Visual Studio Code, I have my terminal open right here. If I run .NET info, it's going to tell you all the information about the version of .NET that I have installed, and you can see I'm running .NET 5. This is .NET SDK version 5.0.100. All right. So C#9 will not compile on an older version of the SDK. You must have the 5.0 series SDK or later. So certainly if you're watching this in 2022, 2021, whatever, what have you, your later version will support this. So let's start talking about the first feature. And I've got, this is a simple console application that we're using so that we can very quickly and easily run our application and see the difference. So first thing I want to talk about are records. Now, why do we need a record? What's a record? How's this different, better than what we already have? So, oh, you're not going to jump through for me, are you? Fine. So records, right? That'll jump. There we go. Records are a way for you to create a new reference type, right? We know that we have value types and reference types in .NET, right? Value types are things like an integer or a double or a decimal, right? They're stored on the stack, the memory stack, so they're cleaned up very quickly and easily. A reference type like a class is stored on the heap, and that has to have a garbage collector come through and clean it up. A record is another reference type, just like a class, and you can define it using very much the same syntax as a class, except instead of calling the class keyword, you use the record keyword. So here's a person record, and I've defined two properties, first name and last name, and a constructor, public person, string first, string last, and I'm going to take those two arguments and set them to the two properties inside the person. Pretty easy to do using this little value tuple comparison and setting there. So let's talk about this. Let's dig into this a little here, because there's some interesting things that happen. I've added a lot of syntax here, and I can very quickly say, give me a new person, and write out the information about that person. The record, and I mentioned this earlier if you weren't here, this is syntactic sugar. This is just a wrapper that you use inside of your code that actually generates a class when it compiles. The compiler is doing a little bit of work for you and generates a class for you. So if I run this code the way that it is right now, let me just make sure, right way. I don't know why that's being a little grouchy. Let me go into the sample console and .NET run, and it's just going to tell me here, because I'm telling it, right line P. Look at this. I get this format, person, first name Jeff, last name Fritz, when I created a new person record. If that was a class, I get this weird format, right? So if I create let's person class, right? Let's just put string, first name, string, last name, and right, let's just new person, first name equals Jeff, last name equals Fritz, right? Oh, this needs to be person class, right? If I do the exact same thing again, right? Oh, you're gonna be grouchy with me, are you? What did I hit here? There's no argument given to the requirement first of records person. What? What did I break here? I didn't. Save that. There we go. So I get, for the record, it formats like this. But for a class, I get this weird reference to this class type. That's weird. That's strange. That's right. That's annoying for me as a human looking at that string type. My toString should tell me some information about what's actually inside that class, right? And you'll see folks will, right, they'll go and overwrite this, right? And they'll return something, right, that looks like first name, last name, use a little string interpolation here, right? And then it actually gets a little bit closer, right? But it still doesn't tell you that it is a person. So I get this nice formatting here that the record type generates when it is compiled. It gives us this toString override that looks nice, tells you what the name of the type is, and puts all the properties next to it with their values. That's not bad. Okay. What does that do for you, though? What it does is it allows you to compare the records for equality a little bit easier, a little bit friendlier. This way, right, I'm interacting and building these record types that behave more like a value type, behave a little bit more like a number, right, or a struct, without some of the nonsense of being a struct. So, Thindall asks, let me bring this up. I'm going to pause every now and again just to make sure I catch up on questions in chat. And one shot, that's a fine comment. Let me bring that up as well. So Thindall asks, does the constructor assignment syntax work on a normal class as well? So where I did this, so there's what's happening here is the record also includes a deconstructor. but I believe you can use that same syntax to do assignment as well. I believe that works. And the arrow here, right, that's right, that's actually equals and greater than, but when you bring them together, the font I'm using turns it into an arrow for you. So that should work in a class. Heck, let's try it, right? I mean, why not? Let's see if it works in a class, right? Change this back to person class, and up here I can say, instead of new person class, just get rid of that and that. Let's see what happens. .NET run, and away we go. I'm missing a parenthesis on, where's that? Oh, okay, that's on me. That's on me. Here we go. Let's try it again. See what happens. It works. So you can use that same syntax. Okay. Now, Marcus, you're getting a little ahead of me here. That's 1 or 2 steps down. So let me get into Ratawar's question there as well. And oh my gosh, wow, Professor A. Heil, thank you so much for that raid. 112 folks into the channel. Welcome in. Hello, raiders. My name is CSharpFritz. This is C# with CSharpFritz, and we're learning the new features in C#9, covering some of the basics. We're going to get into pattern matching a little bit later. Thank you so much for the raid. Much appreciated. I completely missed that because I was following along and working through some code here. Hello. So let me get into, there's a comment here from One Shot. Looks like standard JSON, and I think you're referring to the format that was output by the toString method that it generates. It's not quite standard JSON. Not quite. It would need quotes around those, but it certainly gets close. So, Ratawar asks, would you say a record sugarcoats classes? Yes, absolutely. A record definitely gives you the ability to make classes that are simpler. And certainly when you're trying to create those POCO objects, those plain old CLR objects, where you're just passing data from one object, from one location to the next. Maybe you're creating a view model where you want to capture data from the user interface and pass that along to something else that's going to do the business object, the business logic. Makes perfect sense. You can add methods inside of a record. That's possible, but I'm going to get into the comment that I saw here from Marcus. A record is by default read-only, and when we add features to our record, like declaring properties like this, we're adding those properties and making them appear outside of the default read-only immutable structure of the record. Let's get into that. This is what we call a positional record, right? That's what they call it, positional. How you doing there? Is that Kianji? Hello, welcome in. Good to see you. Thank you so much, everybody, for joining the chat. Much appreciate the crowd here today. And I'm keeping an eye on moderation. Make sure that nothing gets too far out of line. Let me catch up with NetJam Jr. Here with a question. Is C#9 support going to be exclusive to .NET 5, or is it going to be supported by .NET Core or Framework? It is exclusive to .NET 5. They are not backporting this to the older frameworks. Sure, let's is that a taser hat asks, can we use p.firstname on records as well, like classes? Absolutely. Let's do that, right? So I just said right line p there. I can certainly say p dot, and I get all of my properties on the record just like I would previously, and I'll .NET run, and you can't see it, it's behind the comment there. There you go, it just wrote Jeff. So not a problem, easy to work with, easy to interact with. So Thindall asks, are there any breaking changes in C#9 from C#8? No, there are not. Strictly adding new features going forward. So next thing that I want to get into is, well, read only. Can we change the object, right? Let's try interacting with. Nope. Well, particularly, right, my person record here, because I don't have a set, right, it's private, you can't change that. But if we get into a positional record, right, am I saying that right, positional record, we can, and you're not gonna let me collapse this, are you? Pain in my neck. Fine, be that way. We can, when we get into positional records, we're going to be able to create these without writing a lot of that inner content. And it also generates equal statements here. So this was, right, so if I create a second person, you'll very quickly and easily be able to compare and get that they match. There we go. True, it does match. Even though it has the same name, even though it's not technically the same person, all of the values of the properties are equal, and it matches and it outputs it. Yes, the compiler has gotten additional features to support this. It's the compiler that's delivering it, but it ends up compiling down into classes, reference types, and very much the same things that we had previously. There's a question here from Baranad 6. Is there a way to use C#9 on UWP? I do not think so. That's something that's going to need, those frameworks need to update so they work with .NET 5, and then you'll be able to do this. I believe they're trying to do that, get WinUI up to speed with it. Diego asks, hey, what's that thing that appears on the top left showing my key presses? That's called Karnak. Karnak is a tool that allows you to see the hotkeys that I'm pressing, so that you can follow along and maybe learn a hotkey or two along the way. So, all right, yes, C#9 does work in Blazor. All right, let's get into the next set of features that I want to talk about around records. Inheritance. And actually, wait a sec, did I do the positional? No, we're gonna do the positional right here. So, demo 2. We can create these positional records. Right, let me comment these out so we do just the first one. You can define a record as one line, and it almost looks like just a constructor there, right? I mean, it's public record, and here are the values that I'm going to use in my constructor to make this. Now, by default, a record is read-only, and when you define a record with this syntax, it's going to generate property assignments for you, properties that you can read, but you cannot change, named first name and last name, with exactly that that casing. So if I define a cool person with first name, last name, and I create a new cool person named, okay, I guess, write line and write that out. If we run that, it's going to output very quickly cool person, first name, last name, and they're positional, right? It if I change the position of these, right? If I make this last name, first name, and rerun it, well, it's last name, first name. It doesn't go and reorder them because of alphabetics in it. It's whatever position those appear in, that's what it outputs. Okay. But they're read-only. I can't go in and change that, right? And I get all of my IntelliSense. Those properties are there on this record. But I can't go and change first name. So it's already giving me an error here. Sorry. This is an init-only property or indexer. And init-only is coming up in the next segment. So you can't change it. You're going to get an error if you try and run that, right? Sorry, can only be assigned to. So don't do that. Now we have inheritance out there, so we can create, say, a rock star, right? And that's just another cool person, right? And a rock star belongs to a band, so we can add an extra property there, the name of their band, and will inherit from cool person, same way we inherit from other classes when we have class syntax, with a colon, the name of the type we're inheriting from, and first name, last name. We're passing them into that other type. Consequently, then, we can right, we can create a new rock star, Freddie Mercury, in the band Queen, and we can write out that information. And, right, we'll end up getting this information, right? Rockstar, first name, last name, band name, Queen. So you can now have these cascading types, right? You can define these very small and quick for us as humans to recognize record types and be able to interact with them to pass information around. So... yeah, Kirk, we're gonna that coming up. Look at the man. Spoiler alert. So Thindall asking, what does the toString look like? And there it is. That's what that inherited record looks like. Rockstar, first name, last name, and it doesn't show that it is a cool person that inherits from cool person. It's only the type that we've defined here. So, all right. Now, you can cast that back, right? I can cast, well, let's leave Freddy here. I can cast Freddy back to a cool person. That is possible, right? But when I run my code, it still sees that it's a Rockstar object. Even though it cast it back to cool person, you still get the fully defined object being interacted with. So you want to do a nested record. You want to do a record inside of a class? I'm not quite sure. Let follow. Yeah, interacting with database records and be able to bring out those database records. Since you're not doing methods on a database record, you can interact with them by defining very quickly and simply, here's what it looks like. I mean, the syntax for this, nothing says you couldn't, right? Format so it looks something like this. And now it matches up with, right? It looks a little bit more like how you define your database records. Sure. They're read-only, you're not changing them directly and passing them along to interact with the database. So Not bad. But they're immutable. So let's get into demo 3, where we're going to talk about deconstruction and cloning. So demo 3, I have a new cool person. Hey, what can I say? And we can deconstruct, we can break that down into the individual properties that are defined as a tuple, right? This is deconstruction of value tuples. So we're taking that person, break it down into its component parts, and I can then interact with those variables independently. So right now I've got each one of those values loaded separately. Okay. That may be a way that you want to break out the various values of your record so you can interact with them. And when you want to then modify the record, we have a with expression. And what this does is it clones. It's a generated method that happens behind the scenes by the compiler that generates a clone method that you can't call directly, but the compiler will call when you use this with keyword. So let's take our record type P, our cool person, and we're going to modify and clone it into the S variable. And when we look at S, you'll see it's another type of cool person, but it's a clone, right? It's a new instance. I haven't modified P. The variable P is still out there, but right? And heck, let's write P as well. We've created a copy of our record. So this allows you now to modify it, and when it comes time to update and send that record back somewhere, well, you have a new copy, send that new copy back to whatever your calling method is, and you're able to inspect and apply those changes. That's right, Kirk. If you want to just copy the object and you don't want to modify, you can omit any of these property changes, and it will give you the exact same copy of that object back. Now, this is called a shallow copy. It copies just what's at the property level, right? It won't go down into anything else, but it'll copy just those objects. Give me a little bit more context there, Diego. I'm not quite sure what you mean by can you clone but with another type. Give me some more what you're looking for there, and we can dig into that. There's a question here from, is that Karthikeyan S. Two records with the same values have the same, or they're, I'm not quite sure. Not the same, they're not the same reference, but they are equal. They're placed differently in memory, but all of their properties can be tested, and they will be tested as equal. So I'm reading through some of the questions here. Xerxes, that's a fine question. Let's look at that. Can I clone P but cast it as a rockstar? Cast it to the descendant type, passing through the band name? I don't know. Let's give it a try. So from demo 2, I had cool person and I had rockstar. There they are. So I have cool person here. Can I do something like this? Now, actually, I think you would need to do, if you want to pass through the band name, equals, I don't know. What do I get? Object reference not set to an instance of an object on 104. Doesn't like it. It's a more specific type. So it's not doing it. Right? So no. And if I try and go this way, what happens if I do that? What do I get? No, can't do it. So, clear first, and back to like that. Dolkanu asks, are generics supported? No. Nope. So, all right. Yeah, the reference equal is false. It's not the same, but the derived equal that it creates will show that it is equal. So, looking here. All right. So, those are records. New feature in C#9 that you can interact with, you can work with. Hopefully makes interacting with and building smaller, faster data easier. And I was told by the ASP.NET team you can use records with model binding in ASP.NET. I believe that means it'll also work with Blazor. So, let's answer this question from Kirk. Are records and anonymous objects related in any way? They're related in the sense that they both, at compile time, generate classes. An anonymous object, you aren't going to know the name of the class. You're not going to be able to reference it. However, a record, you can reference elsewhere in your code, elsewhere outside of your code if you mark it public. It is available. It is a named type. Yeah. So, all right. Let's head over to the next demo I want to talk about around init-only setters. So, we know that when you create an object, right, you can create properties and mark them as read-only. Right? Actually, these are fields. They don't have the get set on them. But these fields can be marked as read-only, and the only way they can be modified is in the constructor. Right? So I get errors here trying to create a new log entry object here because these are read-only fields. You're not allowed to interact with them. So this is a problem. Right, I want to be able to assign these without having to create a constructor that explicitly assigns to these. Let me come back to your question there, Null Peer. Let me come back to that. So if I wanted to assign to these, I need to create a constructor that explicitly does the assignment, and I'm creating then syntactic sugar in a constructor that. This actually is a little bit clearer what's actually happening when interacting with my log entry object. So, I mean, if I want to allow these to be modified outside of this, right, I might do something like this, right? Come here, you. And now this will compile, but these values can always be set. They can always be changed. I'm not protecting them from modification outside of this class. If I want them to only be able to be initialized when I have a initializer like this, this is where the new init keyword comes in, right? I mean, I could mark these as, right, private, and that's not going to work, right? I get the exact same feature if I delete the private set. Private set is, once again, syntactic sugar, for it can only be set inside of this class. So if I want to make that available so that it can be initialized up here, you use the new init keyword. Now, what do you mean already defined? So if you add this, instead of set, there we go. Now what this says is, at the point of initialization, so either construction inside of a constructor or with an initializer like I have up here on lines 18 through 22, when it's being assigned, now, right, I've limited the scope to when that can be set to just at the time that the object is being constructed. And it cannot be modified later. Right, and log severity error, right, change it, info, right, and cannot be modified. So this is a way for you to protect how your code is being interacted with. And clear .NET run, and this will work. Okay. So it formats properly. I have a nice toString that I overrode down here, so it formats and gives me that. Let me answer NetJam Jr.'s question, and I will back up to noun. Is it NounPeer's question? NetJam Jr. asks, can you have init and set defined separately? No. Init clearly says you can only modify this at the time the object is constructed. Outside of that, you can't go any further. It cannot be modified. That property is immutable. It cannot be changed inside of here, right? I can't add a do the thing method here and say description equals haha, I erased your description, right? I'm already getting an error here. Look at this. Sorry, can only be assigned in an object initializer. Gone. So you can't. You can make this, you can put a scope on it, and now it can't be modified outside here because it's outside this class. I can make it internal, and that'll work, but it won't be able to be modified outside this library, right? So you can add that scope, but you won't be able to modify later when you use the init. Yes, you did have to write a bunch of code to get this behavior before to protect and add backing fields, all kinds of crazy stuff. So I'm not going to go down into reflection. That's a little bit too deep for this class, for this session. NounPeer has a question, though, backing up just a little bit. Before, when you wanted to make an immutable object, that's an object that cannot be modified. It's read-only. But able to modify its properties, you returned a new instance of the object. Can you do that with records? Yes, so with records, the way to do it is the with keyword. You want to create a new instance of the object that is modified, that has those changes made. You use the with keyword that we saw here. Where'd it go? Right, I had this, right? So I want to modify it and start using this new, right? I would say first name equals Scott. And now it does the modification and returns the new instance that you would work with. So, let me see here. Kirk asks, let's put this one up. Let's give this a try. Can you use backing fields with init? I don't know. That's a good question. Let's give it a try. Let's see what happens. So maybe instead of log, right, if we have right, private date time, let's just call it log time. Return log time init log time equals value. I don't see a compiler yet. It works. So that's interesting because you would then be able to modify this later, which kind of defeats a bit of the purpose of init. However, maybe you have some initial checks that you want to go through, some initial methods that you want to review as it's coming in. Sure, you can do that. But being able to change it after the fact, the backing field, feels like you're losing a lot of the value of why you put that init constraint on your property. So all right, so that's what an init, what the init scope is. It loses a bit of value. So if you allow that to be modified, right? And of course, because it's init, I can't change it. So, all right. I didn't create a number 3. I didn't create a third demo here. There's a reason for that. Because the third demo is top-level programs. The idea of a top-level program is you should be able to build applications by just creating a file and writing code into it. And it should just pick up and run that. So that actually takes higher priority than a static void main. So let's add a new file here, and let's call this, let's just call this start.cs, right? I'm even going to put 3 in front of it. And I can do very simple system console write line. This is a top level program. I don't have any other top level statements. This is a top level program. So I've added another file into my program and it's running this instead of what was in my static void main. Huh. You can, like that, like the warning said, you can only have one file that has a top level interaction. If I flip that out, it now goes back and runs my second demo. But think about what you could do with this. You can start writing something that's a little bit more script-like, right? That means that I can just start interacting directly with methods, directly with objects from here, right? I mean, inside of my records demo here, right, this is called records, and I can reach in and call records demo, right? So, right, I could say, come on, sample console, no, records, demo and reach in and call that directly and start tinkering and learning exactly what I need to interact with here. So, and you see I even get a warning here that it's ignoring the program main entry point that normally it would interact with. But think about this. I can add a .NET watch run statement, and it will watch this, and as this changes, run appropriately. So there's nothing keeping me from just quickly making changes, seeing it recompile, and immediately getting the output, immediately knowing how that worked. So when you're building libraries and you want to be able to test and interact with and do something a little bit more complex, this becomes a little bit more interesting. And I'm only writing one line here, but there's nothing keeping you from writing several lines, right? Right? And I can put using statements in here as well, right? Using system, using sample console, so those are just there. Console, right line, this is a top level program, save, there it is, compiling, running, this is a top level program, and the output. And later, right, I can add configuration into my project file that says, well, when you build for release, don't include this, right? This is just my test file that I have here that I interact with. Or maybe you add into your git ignore, right, or whatever source control you're using, you add indicators that say, well, don't include this file. This is my test file. Don't include this when you commit to source control. So yeah, you can use this to create very minimal APIs. You can absolutely do that, right, and get some very, very small applications that are just a few lines of code and interact. I see a couple questions here in chat. Let me go to these and we can talk about this. There's a question from Kirk, question from Marcus. I'm going to queue those up. So let's go to these. Kirk asks, what if you have two files like this? So it's already telling you here, only one unit can have top level statements. So if I add another file, right, we call this another file, CS, system, no, another file, right? So I saved there. Now see that .NET Watch sees a new file and it doesn't know what to do with it. Try and run it now, and it errors out. Whoop, only one compilation unit can have top level statements. You can have only one file with top level statements. So get rid of another file and rebuilds. Gives me the warning and it runs properly. So you can only have one file up at the top. Marcus asks, do you lose the ability to pass in arguments with this? No, you don't. There are notes on how to do this, and I'm forgetting what it is. If we look in here, top level statements, you can reference the arguments. Where is it? And you can also output directly. You can run asynchronously. I'm forgetting how to access the arguments. I forget how to do it. And it doesn't say here. Top level statements can access an array of strings named args. There we go, it's named args. So let's go back over to Visual Studio Code. And we can say a console right line. These are the arguments passed in. Save that. And it rebuilds, and it's giving me a system string collection. So let's .NET run and foo. Let's pass in foo and bar, and it should pass those in as arguments. You're gonna give me that string join. So that we get that appropriately. Try it one more time. There we go. Foo and bar it finds on the args. You can have this run asynchronously if you'd like, and it will behave appropriately. And you can even return exit codes if you'd like. Right? And back down here. And it will return an appropriate non-zero exit code. So we don't see it here, but it could break things appropriately. I agree, Jeremy. There are times that folks don't want to do that, but I would prefer to run a test project. To each their own, but flexibility. This is what you have. So, completely agree. Nowmpir asks, would you need to still create a console app? Wouldn't that defeat its purpose? Well, here's the thing. All of the .NET 5 apps are, when you boil it down, console applications. They all do run on the command line, whether it's an ASP.NET Core application, a console application like this, it's a Windows service that you might build, a Linux service. They all, even WinForms and WPF apps, have a static void main that you can override and call in this way, and it'll interact with the console. So, yes and no. You don't need to create a console app, but it'll interact with the console. So, looking here. All right. So, that's what a top-level project is. All right. And I'm just going to comment all of this out so that I'm sure it still runs. There we go. That's a Konzader Shad asks, I hope I'm pronouncing that right. How can we execute these lines from other files, classes, methods? You can't. You can't. It generates effectively a static void main. But the goal here is these are ways to just kick off a thing. You're right. Chris says it very nicely there. You wouldn't just put them. You would put them into a properly namespaced file or class. So then you can reuse them wherever you'd like. So, all right. Now I haven't talked on this series about pattern matching. So let's get into pattern matching and talk about that a little bit, because I got a lot of demos for pattern matching. So I'm going to admit up front, pattern matching is not a feature that I prefer to use. It makes your code a little bit easier to read, but it's generating different conditional interactions with the types that you're interacting with. Pattern matching was introduced back in C#7. So if you have older applications that are the initial set of features up until I get down to the C#9 samples down here, these first 3 sets of demos, these all work with .NET Framework. If you opt in and choose to use C#, well, if you're using .NET Framework 4.8, these all work. Okay. So let's talk about basics of what pattern matching are. Pattern matching allows you to match on the shape of an object, not necessarily the value of an object or testing something specific about the object, but the shape of it. What does that mean? So instead of just doing some sort of a type check or doing any kind of interaction to see whether values are set or not, we can do this type of pattern match. So if we define an object called data, and we'll assign it to 1. If data is int I, so this says if data looks like an integer, if it's in the shape of an integer, stuff it into the variable I. And we can then work with it in the block after this. Similarly, else if data is double, and we provide the variable d, well, I'm going to right line that. Else right line, hey, just give me a number here, right? So let's .NET watch run, and that was an integer. If I make this into, right, a double, it's going to fail the first test, pass the second test, and it's a double. So you have ways to test for the type. And this was one of the initial features that was made available with pattern matching. And that gets you somewhere. But you can also test against with switch statements. So if we take a look at using switch statements, if we have, in this case, data equals 0, we can now case and do the same type of pattern match. So we're switching on the data object, and if it's 0, if it equals 0, we're used to seeing that, we're going to right line 0. But now we're going to test for the various types. Case double, it's a double, and we'll stick it into the variable d. We'll write out double. We can also use a when clause with this to do additional testing after we match the pattern. Case int n when n is greater than 0. So if it is an integer type and that number is greater than 0, write this out. And we can also pattern match against the keyword null. Case null, well, give me a value. Otherwise, we'll write out, well, you're boring. All right. So if I save that now that I changed, the value 0 is passed in. And if I give it a positive integer here, rerun it, and it tells me it's a positive integer because it fell through to here. If I give it a negative integer, it's going to fall all the way through because it fails the when test. And now we get down into, well, you're boring. So when was added back in C#7 as part of this basic set of pattern matching. Very basic. Can you use float instead of double? Sure. And I mean, it's not a float. Right. Didn't like that. Make it force it to be a float. Since it didn't have a syntax after it, there it is. Now it thinks it's a float. It's a double by default. So that's a basic switch statement, but you can, starting with, I believe in C#8, you can inspect properties when you do that match, when you do that switch. So I've defined, let me close these up. I don't want to show these just yet. Some objects down here. I've defined a vehicle, and a vehicle has passengers and a number of wheels. A car is, well, it's just a vehicle that has 4 wheels. A truck is a vehicle that also has the property total weight. So if I go up here, I can calculate the toll for a vehicle. I'm not going to define a vehicle to start, but we can say, well, let's take that vehicle and let's switch and inspect the patterns, right? Inspect the properties, right? We're matching against those. If the value of the wheels property is 2, it's 25 cents. The toll is 25 cents. If the value of the wheels is 4, it's 50 cents. And I can combine this also with the type interaction. Well, if V is a truck T, right? There's another pattern match. And here's my when test. When T total weight is less than 10,000, well, then it's $1. And here's my else. This is a switch statement, right? This is not a switch block, but this is what we call a switch statement, because it's very quickly specifying, here's what we're switching, the vehicle object, and we're matching on these. And instead of having some value that we're setting, we're returning this into that value. And we don't need break statements now as well. It gets very terse, very quick. You get into the syntax of this, and we can return, here's our interactions. The underscore down here is a special character in C# as of C# 7 called a discard. It's a way for you to say, well, ignore whatever this thing is. In a switch statement like this, it's the default. This is what we're going to return. So down here, I will just say right line the toll, right? We can say toll assessed is, right? And right, we can make this currency, right? So it'll run this, and there we go. Toll assessed is $2 because, well, there is no vehicle. We don't know what the vehicle is, so it's $2. But if I make this a new car, right, and I make the number of passengers 2, it'll match and return my toll assessed is 50 cents because a car has 4 wheels. If I make this a truck, right, well, now it's a truck, and total weight is less than 10,000, the toll assessed is $1. So very simple way to interact, and hopefully this gets a little bit easier to write and interact with building what could have been some really intense switch case statements, right? Being able to check these various properties, these various the shape of our vehicle object, and set that to a value. This would be a messy if-then-else statement with lots of if and else's and all kinds of things. So, right, that's the stuff that we're learning here. So let's now run into the rock, paper, scissors sample. So we can also match on tuples, value tuples. So value tuples we've seen are these parenthesis, comma, parenthesis syntax, right? And we're testing for a match on these. And we get the logic for the rock, paper, scissors game very quickly here. If the first is rock, the second is paper, rock is covered by paper, paper wins. If first is rock, then scissors, and we end up with all 6 scenarios here. So I can execute, I can call this and get some sort of result string telling me who won, but because it does this simple match. That's pretty cool. This is a way for us, right? Think about all the if then else logic that you would have put together, but it gets very terse, very clear and quick here how to express the 6 different scenarios, 7 including the tie, that make up the rules of the rock, paper, scissors game, right? So if I change this and I have rock and scissors, it's not going to do anything. Yeah, cannot be accessed. Did I forget to put Let's take static out of there and let's right line the result. Right line the result. Save that and let it go. Here we go. Rock breaks scissors, rock wins. All right. Paper. And rock is covered by paper, paper wins. So it's going through, it's doing those matches clearly, quickly, and easily, and it's something that, right, we can start interacting with to make our code simpler. I love that how terse it gets. Very easy to express the full syntax of this. The challenge is other people need to be able to read this. So, right, I may get these lined up so that they all are perfectly lined up and it's clear. Here are the scenarios that my switch statement runs against. Takes a little bit of time getting used to seeing that syntax, but I think it works very, very nicely. So, just double checking here. Good. It is something you have to grow into. It's not a required feature, but this is syntax sugar. It's going to make your interactions easier. Now, let's actually get into the new features in pattern matching that are available as of C#9. And first is they've simplified the pattern match. You don't have to specify the type of the object that you're casting into that you're matching, right? If it's matching that it is a truck, you don't have to capture it into the value t, and I didn't write out the toll here. Right line your toll is toll C, right? That should have picked up, right? What do you mean you don't know what that is? It should have done that as a format. Why don't you like that? What am I missing? Oh, it's a colon. Thank you. I can get rid of those, right? Much better. Too much notation. There we go. Your toll is $2 because I didn't pass anything in. So let's make it a truck. We pass in a truck and your toll is $1. Right? Make it a car. Well, car has 4 wheels. It's going to be 50 cents. Right? I could make this a Reliant Robin, right? Doesn't know what that is. So your toll is $2. So you can mix and match. You don't need that T there, and it will still match and just work. You had to explicitly capture what it was casting into. You don't need to do it anymore. Okay, that's fine. It was, I mean, some folks would even add the discard here so that, okay, I need to put something there, capture it, but forget what it is. Now you don't need to. If you don't need the type, you don't need to include it. It'll do the pattern match and just discard. So, here we go. So that simplifies things, makes it a little bit easier to interact with. It's not, no, I wanted to go relational patterns. So the next one to look at is we can now match against comparison patterns like less than, greater than or equal to, less than or equal to, and interact with this. So now, right, I can do a switch on that property value and do my comparison here. So instead of having, once again, if then else, right? If then else if, right? Else if, I can very quickly test against total weight and set that toll appropriately, right? To apply these different conditions and output that value. Thank you. So your toll is $2 because your weight is 9,500. That's less than 10,000, but it's greater than 5,000, so it comes up $2. And you can even get these joined together, right? You can use some of the logical terms that you might have expected to be able to use. Where is it? Yeah, logical patterns. So now, instead of just doing less than equals, there we go. I can also put an and in here. You can do or and not as well. And or not are the keywords you can use between patterns that you're matching. Ah, okay. Now we're talking. So these are, it does feel very Visual Basic, right? These are ways now that are going to give you a little bit more English, a little bit more human readable friendly way to see exactly what it is you're interacting with. So 9,500, that's less than 10,000, but it's greater than or equal to 5,000, so it's a $2 toll. There you go, right there. You like the simplicity, you don't like the idea of having to remember to go to that function when a new class is implemented. We can structure things differently. Yeah, if you have much more composition happening in your project, right? This is a very simple example to get right into the interactions and how you can very easily see how the feature works. So those are the new updates in pattern matching that we have. Now, the last feature that we're going to get into, and look at this, I am just about on time. Amazing. Can we remove var toll? Well, I need to assign it into something. I'm assigning a value here, right? I mean, what are you doing with that value? The switch statement assigns a value to something. So these tutorials actually come right out of the docs that I'm showing you. All of the code here will be available. It is out on the GitHub repository. You can go to that location and you'll see it. So there are a bunch of pattern matching demos out there as well. But I've simplified the toll matching for the purposes of this discussion. So, let's talk about the last feature that we want to get into today. The target typed new expressions. That sounds kind of weird. Check this out. If you've got a type that you're explicitly referencing, you don't need to put the type on the right-hand side of the equals. Because that's just annoying. The compiler knows what type you're going to create and stash in there. So you don't need to put all this other goo here. You can just say no. And it'll just work. But that also means if you're referencing and you want to create, say, an array, you want to create a group of different things that are in here, well, you don't need to write the same right? That type again and again and again. I put it in the wrong place. Right? That, while that's nice, it makes it very clear, very explicit what it is you're doing there. You can get very clear, make your code a bit more tight on screen by just adding these new statements without it. So, and you can see when this runs, numbers.length, just the number of elements that are in the array, and it will return 3. So, yep, if the left side of the statement knows what type it's going to be receiving, you can just use new to assign into it. Similarly, right, let's create another method here. Maybe I have a, right, let's create a count elements in list method. I don't know, I'm making this up here, right? My list, right? And I'm going to return my list dot count, right? Right, so this is an, yeah, I know. Right, this is a local function inside this function, inside this method. So I could do something like, why don't you like that? Cannot be used like a method. Yes, it can. I just don't have the link there. There we go. So I could do right line, count elements in list, list count, right? And I can just say new, and it'll pass in just a default new item. I forgot the void. Go back up here. So it'll pass in the default. It knows the default constructor to create one of those, so the list count is 0. I can still load this up and start, right, putting things into this. And it's created a new list, and I'm just populating it. I'm initializing it appropriately there. 6. So the new statement, wherever you're passing in, wherever you're creating a variable, you're creating an instance of some type, and we know what the expected type is in that target location. You can just use this new syntax, and it will infer the type appropriately because of the target that you're dropping it into. Okay. It is, Marcus. It is exactly the reverse of var. So where we used var because we had on the right side, here's the type that I'm declaring, and I needed some signature of this is what it is. You can use new now to just create and use the default constructor and pass that around. Actually, I believe you can jump right into, right, well, new with whatever constructor arguments you want to pass in. So there is no rush for applying this into with production code. Oh, tabs, beep boop beep, tabs. Tabs are accessible, spaces are not. Other developers can change the size of their tabs, change the size of their font appropriately, and it continues to be readable for them. Where spaces, if you change the size of your font, change the size of your screen, change the font face that you're using, becomes unreadable. The API changes up to .NET 5 or Taylor and Code has a question here. Yes, support-wise, you are correct. .NET Core 3.1 is supported for a year after .NET 6. Actually, I think it's going to be 2 years. .NET Core 3.1 came out in 2019, so you get at least 3 years support. So that'll be through 2022, I believe. That'll be supported. It's 2020. It's 3 years or 1 year after the next version is released. I don't think it shortens. It's at least 3 years. So. Is .NET 5 supported on Azure Platform as a Service? Yes, it is. .NET 5 is a current release, so it'll be 3 months after the next release. So if the next release is .NET 6 and it comes out roughly in November 2021, .NET 5 would be supported until February 2022. However, and some folks have said, oh my gosh, I don't want to migrate and have to change my code so quickly. Here's the thing. The migration from, and from, you'll hear this from many folks, to go from .NET Core 3.1 to .NET 5 it's very easy. There's even a try migrate tool that you can use. Check out this session from Philip Carter and Imo Landworth from .NET Conf last week. You can find it out on the YouTube. It'll highlight, that tool will highlight where you may have any breaking changes you need to update. However, for common ASP.NET Core applications, Blazor applications, the migration is typically fully backwards compatible. For the array of projects that I've updated from .NET Core 3.1 to .NET 5, the update has been seamless. I've gone into my project files and changed the version to .NET 5, and it just works. So, Azure Functions is not yet supported. That is one thing. But .NET 5 on Azure App Service is supported. Yes, and Google does like to cut off support 30 days after they decide, goodbye. Get enumerator support in for each loops. Yes, that's another feature that's out there as well. It'll use the get enumerator appropriately. But these are the 5 big features that I wanted to make sure that I covered that are going to impact, that are going to most dramatically change how you interact with your code. I have some updates that I'll make into the README to include references out to the samples, and I've got very easy write-up here for these things. And I also have a link back to the official documentation. This is in the GitHub repository. I'll share the link again. And you can go out there. All of this code is free for you to use. You're welcome to download. You're welcome to use the references here, drop them into a slide deck, build out whatever presentation you may want to make to your meetup group, to your user group. Maybe you want to do a lunch and learn with folks at your organization, at your business. That's great. Start up a Teams call and you can walk through this stuff with them, or you're welcome to play back the video here or send folks link to this video on YouTube. It's perfectly fine and perfectly acceptable, and that's why we're making this content available. So it's very discussion friendly for you and your friends, your colleagues that you may want to talk with. Pat says a concern with IBM's I shouldn't have said that. Concern is with third-party providers. Definitely can understand that. However, .NET 5, as with, you'll see with the other and with many of the .NET framework versions, whether it's .NET 5, .NET Core, .NET Framework, the compiler, when it builds, will give its best shot to referencing something that may have been built with an older version of the framework. It will try to drop that shim in there and allow you to continue using older versions of things. Consequently, if you built a library with .NET Framework that doesn't reference anything on Windows, that stays very independent and only builds C# things, managed things inside of the library, or maybe it's VB things or F# things, no matter, but you built a library that is only .NET Framework and it is only managed and doesn't reference Windows things, it might work, because it's going to give it its best shot. It might work referencing that directly from .NET Core or .NET 5. Give it a try. It'll break and tell you where the incompatibility is. There are other tools out there that you can run. Check out there's a compatibility tester that you can find that the .NET team has made available. .NET compatibility, I forget the name of it. There's an extension you can get, Portability Analyzer, that's what it's called. There's an extension you can get for Visual Studio that this will run with. There's also a command line tool that you can run this with. So if you're looking at doing an upgrade, you can run this and it will look at all the versions of .NET, .NET Core. Look at that. It even has Silverlight, UWP, Windows Phone support in there. Check it out, and hopefully it'll it generates an Excel sheet that you'll be able to look through and see exactly which APIs are portable, are compatible with the target frameworks you want to migrate to, and give you some idea as to what you need to rewrite. So, all right, I think we're pretty much through here. That's all I really wanted to cover today. Let me head back over to the big chat room over here. Let me stop. Why isn't Spotify stopping? We're supposed to be stopping when I press the stop button. Ah, there it goes. Thank you so much, friends. I really appreciate you tuning in. But this has been a lot of fun. I really enjoyed going through and spending some time talking about C#9 with you. A lot of folks have been asking about C#9 on the all throughout this series, and now you know. Now you've been dipped into the magical waters of C#9 and .NET 5. Thank you so much, everybody, for tuning in. I hope you have a great rest of your day. If you're watching over on if you're watching over on YouTube, I hope you check out the rest of the series. There's going to be links here and here to both the playlist, to the entire C# with CSharpFritz playlist, and to the last video that we were working together on. And I'll see you next week on Monday with another episode. I hope you tune in over here on Twitch and see us live and have your questions answered. Next week, we're going to be talking about database with Entity Framework. Enjoy.